Hi, I'm Miss Love, and today we're going to learn about counting atoms in molecular compounds and formulas. It's really important to be able to count the number of atoms in a molecular compound or a formula so that when we get to chemical reactions and we get to balancing, we can do that correctly. So if you've already been trying to balance chemical reactions and you feel totally lost, this is a really good place to start. So let's start with just learning what are those numbers in chemical formulas. The two numbers that we see are called subscripts and coefficients. The subscripts are the small numbers that appear on the bottom right side of the element symbol or a parentheses in a compound or molecular formula. So we see here, we see these small numbers at the bottom. Those are the subscripts. What the subscripts do is multiply the number of atoms or the number of elements in that molecular formula. So we have, let's see, a subscript, a little number next to an element symbol. What that's telling us is that we have two of those elements. Let's see another. The next example, we have a little 3 next to our element symbol. This is Br or bromine. That little 3 tells me I have 3 of those. Simple enough, right? When we get to molecules, you're going to have lots of elements sometimes. And each of those elements can have a subscript. So you'll see a lot more of these small numbers next to the elements in a compound or a molecule. So in this example, I see a small 2 next to hydrogen. That means we have 2 atoms of hydrogen in this compound. I see no number next to sulfur. If there's no number, no subscript next to the element, that means that there's only 1. But we don't really have to say that because the letter itself, the element symbol, tells us that we have at least one of those atoms. So here we go. In this example, we have one atom of sulfur. Next in this molecular formula, I see a small 4 next to the O for oxygen. That means in this molecule, we have 4 atoms of oxygen. Now, we can also have a situation where there are parentheses in molecular formulas. You may have seen these before, and you may already know what polyatomic ions are. So these are groupings of elements that go together in an ion. They're stuck together, they're chemically bonded, and they can have a subscript that affects the whole thing. That would look like this right here, where we have a parentheses and this number 2 on the outside of it. So that number 2 means we're going to multiply everything inside of the parentheses by 2. So in this molecular formula, we have just 1 magnesium. There's no number next to it. The 2 outside of the parentheses multiplies the oxygen, O, so we have 2 atoms of oxygen. It also multiplies the H for hydrogen, so we have 2 atoms of hydrogen. Let's see another example of that. This next molecule, we have magnesium again. Magnesium, there's no number, so that means I only have 1 of those. This C and N, they're both inside this parentheses. So that means this subscript outside affects both of those elements. So this means I have 2 carbon atoms and 2 nitrogen atoms. We can also have a case of double subscripts. This is like this picture right here where I see 2 subscripts next to each other. One of them would be inside of a parentheses and the other is outside of the parentheses. What do we do in this situation? In this situation, we just combine the 2 things that we've been doing. So let's break this down. Let's go element by element. I see Mg, magnesium. There's no subscript next to that. So that means there's only 1 magnesium atom. When I get to the next element, nitrogen, nitrogen does not have a subscript next to it, but it does have this 2 on the outside of the parentheses that affects that nitrogen. So instead of saying I have 1 nitrogen, we actually have 2 because of the subscript outside of the parentheses. We'll do the same process with this oxygen. The 2 outside the parentheses affects that oxygen, multiplying it, but I already have 3 oxygens. So let's say if I have 3 oxygens times 2 oxygens, so I have both those subscripts, I get 6 total. So I have 6 atoms of oxygen in this molecule. The last thing we need to talk about are coefficients. If you've heard of coefficients in math, this is the same thing. A coefficient multiplies a whole group of things. So in math, we see coefficients before like a parentheses or before a variable. In chemistry, it's the same thing. It's a big number that's in front of some kind of variable. In chemistry, our variables are molecules and compounds. So if I look at this example, I have a big 2 next to H2O. I know that molecule, that's water. This 2 means I have 2 water molecules. That would look like oxygen with hydrogens, but not one of those, but 2 of those molecules. So when I'm counting the atoms for this molecule, I need to count 2 molecules. So this 2 is going to multiply everything in this molecule. So in this situation, I have 2 times H2. That means I have 2 times 2, 4 hydrogens. Oh, look, I even did this wrong. This should be 4, right? Let's see. The next one, I mixed it up. 2 times oxygen with no subscript, so that means it's just 1 oxygen. 2 times 1 oxygen, I should have 2 atoms of oxygen. If you caught my mistake before I did, good job. Let's see if I did the rest of them right. Okay, let's see. We have a 4 next to this big, complicated looking molecule. I have a parentheses here. Let's see. So this 4 is going to multiply by everything. We multiply by the calcium. There's no subscript next to calcium, so that means there's only 1. So I have 4 atoms of calcium. Same thing, that 4 multiplies by the next element, nitrogen. Nitrogen doesn't have a subscript next to it, and there's nothing outside of the parentheses that would affect the nitrogen. So that's pretty straightforward too. There's only 4 atoms of nitrogen. Next, this 4 would multiply by the O3, oxygen with times 3. So we get 4 times 3 oxygens, 12. So 12 atoms of, look at that, another error, oxygen. You know, it's okay to make mistakes. We're all learning here. Okay, let's do the last one of these examples with a coefficient. This time it's going to get even more complicated. I see a double subscript and a coefficient. But we're going to do our process, slow it down, and we'll get it. This 3 multiplies everything in this molecule. Everything. So let's see. Magnesium, no subscripts. So that means we just have 3 magnesiums. The nitrogen doesn't have a subscript immediately next to the N, but this little 2 on the outside of the parentheses does affect that nitrogen. So we have to consider that. We have to take that into account. So we have 3 from the subscript of nitrogen times 2 from that, 3 from the coefficient and 2 from the subscript. 3 times 2 is 6. I should have 6 nitrogen. And finally, 3 times this whole mess here with oxygen. Let's deal with the subscripts first. So I know I'm going to have, actually we can do it all together. We just multiply all the numbers. We have 3 from the coefficient. We have 3 from this first subscript and 2 from the second subscript next to it. So 3 times 3, that's 9. 9 times 2, 18. I should have 18 oxygens. Let's see if I did that right. Yep, 18 oxygens. All right, so we've worked through some examples together. We've talked about what coefficients and subscripts do in chemical equations, how they affect the number of atoms in a compound or molecule. Here is some more practice that you can do. Now these resources, if you're in my class, I will give to you. If you're watching from somewhere out there in the world, I have a folder with free practice. All of these worksheets you have access to. And for your practice, I broke it down into tables. I think it's a little easier to start that way. So the way that you'll do these is fill out first the elements that you see in the molecule. Sometimes that can be the first place we get hung up. Remember, to identify an individual element, we're looking for these capital letters. If we have capitals next to a lowercase, that means it's one element. So this Na is one element because we have a capital and a lowercase. Next, I have 2 letters that we see together often, O and H. But since they're both capital letters or uppercase, I know that they are different elements. Now, in this formula, do you see any subscripts? Any of those little numbers? No, I don't see any. There's no subscripts and no coefficient. So that means I just have one of each of these atoms. Just one. Easy. You'll do the same process for the rest of these examples. The next page, it's the same molecules, but this time I've added coefficients for you to try. Give it a try. Let me know if you need any help. Have a great day and keep doing chemistry.